Hey everyone, welcome to another episode of Let's Lead. And today's problem, we will be talking about a very easy question which has been asked into multiple interviews, and that is the problem of container with most water. The question is fairly simple. We are given an array, for example this one, okay, and each element from this array represents the height of one side of a container, okay, and we need to find those two height such that the amount of water which it can hold is maximum. What I mean by that is, for example, if I consider the first two elements of this array, this one and this one, okay, now area of any rectangle is nothing but the length into breadth, okay. Now what I can do is, the breadth here is nothing but 1, okay, because if we consider it 2 pointer wise, this is at index 0, this is at index 1, so 0 minus 1 or 1 minus 0 is nothing but 1. Now what will be the length or height here? Will it be this one or will it be this one? So consider it in this way. If I try to make a container in such a shape, okay, what is the maximum amount of water it can hold? So it can only hold that much amount of water which is allowed by the smaller size, okay. So it will only be able to hold this much amount of water. Anything beyond this will be spilled. You can keep it in this height at a million times, but that will not be of any help, because the maximum amount of water which it can hold is only decided by the smaller size. In a similar fashion, the height here will be the height of the smaller element, or the value of the smaller element, so 1 here. So the amount of water which it can hold is 1 into 1 is equal to 1. In a similar way, we need to find those two pairs or those two heights which will allow us to store the maximum amount of water, okay. Now the question is, how do we approach this problem? There are two ways, or let's talk about the brute force approach, okay. The brute force approach is simply pick one element and apart from that keep on iterating on each element, okay, rest of the remaining element, and store the value of that area in any list or any variable, and as soon as you encounter a area greater than that, okay, just to highlight, we need to return the maximum amount of water a container can store, okay. So as soon as you encounter a greater area, just replace this with the new area, and in this way you can do it. Now what is the complexity of that? That would be a big O of n square, okay. If your interviewer is good with that, go ahead, it's fine. The other approach which we can apply is, think it in this fashion, okay. Let me clean this. Let's take 2 pointers at the extreme ends. This is the pointer 1, this is the pointer 2. Now calculate the area. For example, what will be the maximum area, what will be the area when pointer P1 is at this point and P2 is at this point? So the minimum value is 1 into this width is nothing but 1 2 3 4 5 6 7 8, 1 into 8. Now the volume is 8, okay. Now how do we update our pointer? Very simple. If I update, if I need to move either of my pointers, okay, how to decide which pointer do I need to move? So just think about it. It will be of no use if I move my pointer which is having greater length or greater height. So if I move this through this one, I'm just reducing my volume. Instead, what I can do is I can move the pointer which is holding or which is pointing to a smaller height. So this pointer is at 1 and this pointer is at 7. So instead of moving P2 to the left, what I can do is I can move P1 to the right. So now the new pointer P1 will be at this height and P2 will be at the same height. Now think about it. This is 8 and this is 7. So the new height will be 8 into the width will be 1, 2, 3, 4, 5, 6, 7. So it will be a 56. Okay. Now what you can do is, this will be 7 because we are considering the smaller height. Okay. So this will be 7 and the width will be 7. So it will be 49. Okay. Now what we can do is, since this is the smaller pointer, we store this variable in our result, and as soon as we encounter any larger volume, we'll replace this result variable value. Okay. Now if I move this here or the smaller one here, I calculate again. This is 8, this is nothing but 3. So 3 into 6, so it will be 18. And in a similar way, when should I, now the question comes is, when should I stop moving my pointer? So in case when there will be a point when both the left pointer and right pointer will coincide and come at a single place. Okay. So that will be my trigger to stop my loop. As soon as I come in at a point, okay, where my left and right pointer coincide, I can stop the loop. And this whole system will have a complexity of 1. Okay, linear time complexity. So this is how we can approach this problem. Let's go ahead and try to implement this. So talking about the implementation, it's fairly simple. We can have let's say a method def max area, okay, which takes in a list of height. Okay, once we have the heights, so as we talked, there could be two ways. One is the brute force way. Okay, the brute force way says I can have let's say a result. I would initialize it to 0 since the area can never be negative. So it will be a positive integer that would be equal, and I can initialize it to 0. Okay, beyond that I can just run a loop for L in range, and when will till when that loop will run, that will run for len of HEI height. Okay, after that for R in range, okay, L plus 1. So this loop, the secondary loop, will run for all the elements which are in forward or which are after my left pointer. Okay, so my right pointer will move to all the elements which are after where my left pointer is. Okay, so that's why L plus 1 until when I can just copy paste it, the len of height. Okay, so this is where I till when where I need to run it. After this, what I can do is, what will be the area? Area will be nothing but the right pointer minus the left pointer. Okay, since the right pointer will always be greater than the left pointer, and multiplied by, this will give me the width, and the height will be decided by minimum of what we have of the left pointer comma the right pointer. Okay, and after this the result will be whatever the max of, since this result will store my value, as soon I encounter any value greater than what my results is storing, that will be the new value of result. So max of result comma area. Okay, and in the end return result. So this could be my one approach So, but this is the brute force approach. Let's talk about the optimized approach, the linear time complexity approach. We can have, let's say, I will name this max area linear. Okay, we can follow the same approach. Instead, what we can do is we can have res will be, let's say, 0. I can define my left and right pointer, that would be 0 comma len of height minus 1, since it is pointing to the last pointer. Okay, last index, since it is pointing to the last index, minus 1. Now till when should I run this loop? While L is, the left pointer is less than the right pointer. Keep in mind, if both the left and right pointer are at the same place, if L is equal to R, that is of no use. Even if L is greater than R, that is of no use. So I should only run my loop unless left is smaller than the right pointer. Now I can copy this exactly. Area would be R minus 1 and height would be R minus L into minimum of the whichever height which we have, and again the result would be the same. Okay, the only thing we now need to do is we need to update our pointers. How will we update it? If, let's say, if height, like we talked about, whichever height is smaller, the pointer of that pointer would be moving. Height of left is less than height of right. Okay, if height of left is less than height of right, we'll move our left pointer plus equals to 1 and increment it by 1. Okay, the other condition could be the opposite of this. Okay, greater than, and in that case we will decrement our right pointer R minus 1. Okay, now once this is done, the only case remaining is when both are equal. Else what could be the result? We could either move the right pointer or left pointer. If both are equal, both the heights are equal, it's up to us which pointer we need to move. I will be using this only. Why? Because if you see now, okay, if you see these two are doing the same thing. So instead of writing it in two different loops, what I can do is I can simply eradicate one condition and write it like this, else this, and I can remove this. Okay, and then return res. Okay, so these are the two approaches. You can go ahead and try it down. This will give me the result. Thank you so much for being here, and I'll be back with another episode.